Hi everyone, today we will learn about the complexity of a program. So first of all, when we are starting any function, any program in the DSA, we have a query like what is the complexity. If we write any code or any program or any function, so we have a first question. We have to first take care of that time complexity and space complexity, what the function we are trying to write over there for the particular problem. So for that question, I have some high level of tips and tricks which we can use while analyzing the time and space complexity of a function or a program. So determining the time and space complexity of a program involve analyzing how the program is execution time and memory uses grow as the input size increases. So this analysis help you to like understand how efficient of algorithm or program in terms of time and memory resources uses. So this time complexity is like refer to the amount of time in an algorithm or a program take to complete its execution in relation to the input size. So it is like usually expressed using big O notation and which provide upper bound on the growth rate of the running time. And factor to consider when analyzing the time complexity, I can say we have like first we check the number of iteration for the particular program we have, how many iteration we are writing or we are performing. So it is also one of the major component for the time complexity to iterate through the loops or recursive call. Second, we have a operation per iteration. So in the how many basic operator like assignment or comparison or arithmetic operation, I think all right, you all know like what is assignment operator or comparison operator arithmetic operation. So this is also one of the major component while iteration purpose in the time complexity when we are measuring. So this common time complexity we can see in our functional program. We have like O of one constant time complexity, O of log n logarithmic time complexity, O of n linear time complexity. This is the type of complexity which we are getting while creating or executing in our functional program. O of n log n is like linear arithmetic time complexity, and O n raised to power 2 quadratic time complexity. Similarly, for the n raised to k is a polynomial time complexity and 2 raised to an exponential time complexity. So these are the like common time complexity which we are getting in our programs. And coming to the space complexity, after the time complexity, space complexity also major factor in the program when we are writing. So in the space complexity is like refer to the amount of memory space used by the algorithm or program. Like I'm using any data structure, like structure I can say stack or some queue. So on that we are using the like we have a space complexity O of n. And apart from that, when we are using the int or dynamic keyword or like long float, on that we have a O of one complexity. That is space complexity. And there is like we are creating the variables. So memory for variables is required for variable like data structure and other program element. And when we are running our program, we have a call stack. We can check from there also like for recursive algorithm how much space is consumed by recursive function call. Common space complexity classes like O of n constant space complexity as I mentioned, O of n for the linear space complexity, and O of n raised to 2 power quadratic space complexity. So these three type of space complexity majorly we are seeing in our program. And while analyzing this complexity, we have to take care of this time and space complexity of a program. We can see like we have to be identified loops, recursive calls, and significant operation in your program. Second, count the number of operation in our iteration. Third, we have expressed the count in terms of input size. Example, input we are taken. And first, like have a simplify the expression to find the dominant terms which represent the complexity classes. Fifth, we have a like if analyzing the space complexity considering like we have a memory used for the data structure and recursive calls. So it is important to note that the bigger notation provide an upper bound and actual performance may vary based on the implementation details, hardware and other factor. It is like useful as a theoretical I'm giving this info. And but when we are writing a function in the practical project purpose, so this thing we have to be keeping in our mind while we are creating the function, and we are calculating the time complexity and space complexity over there. So I think I already given the some insightful information or tips for checking purpose, like I can say in the time and space complexity. So hope you like it. Please like, share, and subscribe. Meet in the next video. Thank you.